In a bold move toward technological independence, India is equipping its Tejas Mk1A fighter jets with the domestically engineered Uttam AESA radar, phasing out the Israeli EL/M2052 system. An AESA radar, or Active Electronically Scanned Array radar, is a cutting-edge system used in modern fighter jets and surveillance platforms. Unlike older radars that rely on mechanical movement to steer their beams, AESA radars use hundreds to thousands of tiny transmit-receive modules, or TRMs, to electronically control the direction and shape of the radar beam. This allows for faster scanning, simultaneous tracking of multiple targets, and a lower chance of being intercepted or jammed by enemy systems. The technology was originally developed by the United States in the late 20th century and has since been adopted and adapted by several countries, including France, Israel, Russia, China, Sweden, and India. India has developed its own AESA radar called the Uttam, designed by the Defense Research and Development Organization DRDO. It is nearly 100% indigenous, with only minor imported components, and is tailored specifically for Indian platforms like the Tejas Mk1A, Su-30 MKI upgrades, and the upcoming AMCA stealth fighter. The Uttam radar features around 980 TRMs, operates in the X-band, and can track up to 64 targets while engaging multiple threats simultaneously. Its modular design allows for easy upgrades and seamless integration with Indian weapons like the Astra missile. By owning and manufacturing its own AESA radar, India gains strategic autonomy, avoids foreign licensing restrictions, and ensures full control over software updates and future enhancements. The Israeli EL/M2052, produced by Israel Aerospace Industries, has been a proven choice for modern fighters worldwide. It's battle-tested in various conflicts and equips jets like the F-16 upgrades for several air forces. This radar boasts configurations with around 300 to 1500 transmit-receive modules, TRMs, but for Tejas, it's tailored to about 900 TRMs, which are the building blocks that generate and control the radar beams. It can track up to 60 or more targets simultaneously and engage multiple in high-priority mode, with a detection range often cited around 150 kilometers for typical fighter-sized targets, depending on conditions. Its strengths lie in mature technology, including advanced modes for air-to-air combat, ground mapping, and electronic warfare resistance. For India, it was initially selected for the Tejas Mk1A because of its reliability and quick availability, especially amid delays in domestic development. The Uttam AESA, developed by India's Defense Research and Development Organization, is tailored for Indian needs and has shown promising results in tests. Recent evaluations in 2025 indicate that Uttam outperforms the EL/M2052 by about 25% in overall performance metrics, particularly in detection and tracking efficiency. India's indigenous Uttam AESA radar has demonstrated superior performance compared to the Israeli EL/M2052 radar in several key areas, including detection range, target tracking, and resolution. For detection range, Uttam can spot fighter-sized targets beyond 100 kilometers, with future variants potentially reaching 160 kilometers. In target tracking, it can handle over 50 targets simultaneously, up to 64 in track-while-scan mode, and engage up to 6 targets with active radar homing missiles like the Astra. Technologically, it operates in the X-band, features 980 transmit-receive modules, or TRMs, and is nearly 100% indigenous, with only minor imported components. By comparison, the EL/M2052 tracks up to 64 targets with about 900 TRMs in its Tejas configuration and remains an imported system, though it offers slightly broader validated ranges in some scenarios. One key difference is in multi-target handling and speed. Uttam excels at faster target tracking and engaging multiple threats at once, reducing the time a pilot needs to react in a dogfight or missile barrage. It also has a lower probability of being intercepted by enemy systems, meaning the jet can stay stealthier while scanning. In contrast, while the EL/M2052 is comparable in tracking capabilities, it might lag slightly in raw processing speed due to older module tech. Uttam's software is also more customizable, allowing Indian engineers to integrate it seamlessly with local weapons like the Astra missile, potentially improving accuracy over foreign systems that require adaptations. In terms of cost, while exact figures are not public, indigenous production often lowers long-term expenses through local manufacturing and spares. The EL/M2052 being imported might involve higher upfront costs and licensing fees. Performance-wise, pilots in simulations have noted Uttam provides a clearer situational awareness, potentially giving Tejas an edge in beyond visual range combat against adversaries like the JF-17 or J-10. Uttam radar remains a critical step forward for India's fighter jet capabilities and will likely play a key role in future platforms like AMCA and Su-30 Mk1A upgrades. As deliveries ramp up from the 41st Tejas Mk1A onwards, this radar could redefine the jet's role, making it a formidable asset in modern warfare without the baggage of foreign reliance.